Didier is a teacher and a researcher at the ETAP, that is a French high-level computing school. I discovered, or he reminded me yesterday that he's been working on XEmax for a long time, and a long time ago. But today he will speak about a new project ETAP, that is a graphical interface to do typesetting demos or experimentations.
Yeah, thanks. Hello everyone. Let me just start by saying how happy I am to see the TUG conference going physical again. It's good to see your lovely faces in real life, in a church. And I'm saying this with all due respect and consideration for the remote audience as well. So I think I'm going to be pretty much preaching the choir if I say, so let me see how it works. Which are the buttons? Oh. No. Down there? That direction? I don't know how that works. I'm only a computer scientist.
This one.
Oh, this one. Okay.
Thanks. The most used one.
Okay. Thanks. So yeah, I think I'm going to be pretty much preaching the choir here by saying that the world of digital typesetting is a fascinating domain. For me, it triggers two huge centers of interest. First of all, it has a strong focus on the aesthetics and the beauty of things. So that's the art of it. And it's also full of interesting technical challenges, and that's the science in it. The motivation for the project I'm going to advertise today is actually double. As for the science part, as a computer scientist and a researcher, I'm interested in the technical challenges in digital typesetting. So I want to be able to experiment with stuff to get a better understanding of the existing algorithms, to play with new ideas and ways to improve the existing things or try out ideas of my own. And also for demonstration purpose, and that's the teaching part of my activity. At some point in a recent past, I had an introductory lecture on the world of digital typesetting for students. It's a bit on hold right now, but I'd like to revive it in a not so distant future, hopefully. And I felt the need to be able to interactively and in a real-time fashion, demonstrate the beauty of nice digital typesetting. For instance, the subtlety there is in kerning and all that stuff. If you think about it for a couple of seconds, you will quickly realize that both of these motivations actually share two common traits, which is the need for a system which would be both interactive and real-time. I think for experimentation purpose, this is pretty obvious. You want to be able to manipulate stuff and visualize the result immediately. You want to be able to maybe hot patch some pieces of code and see if it works better or not. So it's pretty obvious, but maybe for demonstration purposes, it's a bit more subtle. And when I was giving the lecture to my students, I quickly realized that, for instance, if you want to explain and give the feel of the subtlety and the beauty there is in nice kerning, for instance, showing two static PDF pages next to each other simply doesn't cut it. It's much more striking if you have the ability to switch kerning on and off, for instance, and immediately see the characters move around. And that's my personal experience. So once I realized that, I pretty much said, okay, if my two main objectives in my professional activity shared those two common traits, being interactive and also being real-time, then there is probably no point in having two different platforms. And it's likely that a single software may be able to fulfill those two objectives at the same time. And so this is what I want to talk about today. So if you look at the state of the art, obviously you have WYSIWYG typesetting systems out there. Those systems are extremely reactive, and so they can be considered as real-time, but as you all know, they do not, in general, provide the utmost typesetting quality that you can get. On the other hand, we also have things like TEC, which is which produces very high quality typesetting. But on the other hand, TEC is not so interactive. You still have this development, compilation, visualization phases. Okay, so it's not as interactive as one could hope for. Obviously, there are attempts at bridging the gap. Overleaf that we've just heard about is one such attempt. And these are a great tool. But no matter what, none of the existing systems would actually completely fit both goals to be good for demonstration purposes and also for experimentation, maybe for a simple reason, which is that none of these systems, well, I mean, all of these systems are actually production systems. They focus on getting the job actually done, and they are not meant to let you play around with stuff and rapid prototyping things and so on, okay? So this is what I came up with. If you want to understand something, there is nothing that the DYI approach, right? So here's my attempt at a DYI approach. So the system I have is called, I'm still developing, is called ETAP. It stands for Experimental Typesetting Algorithms Platform. Whether experimental refers to typesetting, to algorithms, to platform, or to everything is left to the discretion of the audience. This is what the platform currently looks like. I have it on my laptop over there, so if you're interested, I'd be, of course, happy to further demonstrate it during the coffee breaks, for instance. But for the time being, I have a recorded demonstration that maybe you can play now with the sound, please, because there is the voice as well. So we're going to look at the platform in action for 15 minutes or so.
Let's start with a quick tour of the features of this interface. So at the top right corner, this pane here allows you to select a specific paragraph typesetting algorithm. So here you have the source text, which is first pre-processed into what I call a lineup, which contains a number of objects ready for typesetting. The bottom of the GUI here will display the paragraph once typeset by the selected algorithm. You have the ability to zoom in or out on the resulting paragraph. This doesn't re-trigger the algorithm. This is just a viewport zooming facility. On the other hand, you also have the ability to select the width of the paragraph, and this time, as you can see, the paragraph is going to be typeset in real time. Okay, let's zoom in a little more. So here at the very top left of the GUI, you can select the kind of disposition that you want, flush left, for instance, centered, flush right, and the ability to justify when possible. It depends again on the algorithm that you select. Down below here you have what I call features which affect the lineup, so the original text before it is typeset by the selected algorithm. So for instance, you can switch kerning on and off. I'm not sure if you see the effect of kerning in real time, so I'm going to zoom in a little bit more. So kerning on off. You have the ability to ligature the text, although there is no ligature to display in this particular text here. We're going to change that in a short while. And you also have the ability to hyphenate the lineup. Here it's not going to change anything, but for instance, yes, here, as you can see, there is a hyphen at the end of the first line, so depending on the hyphenation feature, the paragraph is going to be typeset differently. Okay, then you also have a number of visual clues that you can activate or not. I currently only display the characters themselves, but I can also switch that off, in which case here you would not see anything anymore. If you have hyphenated the lineup, then you can also visualize the hyphenation points, which appear here in two different ways. Orange triangles indicate the presence of an implicit hyphenation point, and there is also a blue triangle here which corresponds to an explicit hyphen present in the original text between lime and tree, as you can see. So you can switch that on or off. You can also display the paragraph box, which is convenient to spot, for instance, overfull or underfull lines. You can display the line boxes themselves, so I'm going to switch off character displaying, for you to get a better view of the additional clues here. So line boxes. You can also draw the character boxes themselves, which is actually a nice way to, for instance, to demonstrate the fact that typesetting algorithm usually doesn't care about the contents or the way the characters are drawn. It really is only interested in the characters bounding boxes. So you can draw the character boxes like that. I can also draw the baselines. Okay, I can also display the overfull and underfull box, so there isn't any here. Let me just try to find a particular position where I could get both. So for instance, no, okay. So here, as you can see, there is an underfull box which is indicated with an empty orange rectangle at the end of the line. If I select a narrower paragraph, you can see here a slightly overfull box which is indicated by a filled orange rectangle at the end of the line. Okay. Let me try to find, yes, a position where I have both in case the paragraph couldn't be typeset correctly in that particular situation, for instance, where you have both an underfull and an overfull box. There is another nice facility here, which is the ability to overstretch or overshrink the lines. This is done after the algorithm has decided on a specific solution. So if I click the overstretch option, as you can see, the line will be properly justified, but it will be done in spite of the decision of the underlying algorithm. The same goes for overshrink, which will shrink an overfull line so as to reach the paragraph width, but this time the line would be considered as too tight according to the decision of the underlying algorithm. If you select overstretch or overshrink, as I've done here, there is also another nice clue that you can, a family of clues that you can display, which is precisely the overshrunk or overstretched boxes. I'm going to activate that now, and as you can see, without overstretching, I have an underfull box, but with overstretching, I have an overstretched clue, which is materialized here by this blue arrow pointing upward. It indicates that the line has been overstretched in spite of the decision of the underlying algorithm. And obviously at the near the end of the paragraph here, normally overfull box, once overshrunk, would be indicated with this arrow pointing downwards, indicating that the line is too tight according to the compared to the decision of the original algorithm. Okay, I guess that's it for the features of the general features of the interface. The last thing I can show you is that, let me select a wider paragraph. The text, the particular window in which the source text is displayed here is actually an editor, so I can modify the text in real time. For instance, I could say in olden efficient times, which doesn't mean anything, but as you can see, the paragraph is redisplayed and retypeset in real time. You can also revert to the original text. This will just allow me to show you that ligaturing works, because if you look at the word, let me zoom in again, if you look at the word efficient here, as you can see, with or without ligatures, you get different things. Nice to have a tool like this one for demonstration purposes, and maybe also to help people, for instance students, get a better understanding of how things work. Let's take the example of kerning, for instance. Let me just remove the paragraph box clue, also the hyphenation point. So the ability to switch kerning on and off like this is nice because people will see the subtle differences in the placement of the characters. But on the other hand, my personal experience is that every time I've shown something like that to a bunch of students, there is always a number of them who start thinking that I'm actually a complete maniac. But for instance, what I would usually do is remove this and do something maybe in a more striking fashion like that. So if you look at this and you switch kerning on and off, then the people will start to notice that it actually matters. You have the ability to explain why precisely, and by the way, the ability to show this, to demonstrate this with characters, but maybe also not with characters, but actually with character boxes, may be even more striking, because if you do it with boxes like that, then you have the explicit vision that the boxes move around. It's also maybe it can also be interesting to show this on the full original paragraph like that. Okay, as you can see, the boxes move around, so this is actually quite cool. That's for kerning. The same applies to ligatures. Even in this particular case as well, I will maybe start by not switching ligatures on, explaining what that is, and then typing something like this. Let me remove the character boxes. FI, FFI, FL, FFL, for instance, and then with maximum zoom, I can show what ligatures actually are, okay? So this is actually quite cool. And again, the ability to do it with character boxes is nice because you have the ability to demonstrate in real time and interactively that if you switch ligatures on, all of a sudden you get only one character instead of 2 or 3. So this is also actually quite nice, okay? A word about experimentation now. I suppose you've all been impatiently waiting for the almighty Knuth+ algorithm, and so here it is. So I have two versions of the Knuth+ algorithm here. A full graph one, well actually not the 2 at the power of n graph, a slightly improved version of that, but it's based on the exploration of the full graph of possibilities. And there is also the dynamic programming optimization, which is actually the characteristic of the Knuth+ algorithm. As you can see, even the graph in the graph version, the redisplay is actually pretty efficient, even though it computes the whole graph of possibilities. We can maybe check that everything works as expected. So for instance, here is a position in which the last line is quite full, so it means that probably the looseness would work. Yes, with a looseness a looseness of 1, you get one more line than with a looseness of 0. So it works correctly. I can also play with the hyphen penalties. So let me try to find a position here. We have an hyphen at the end of the first line. So if I increase the hyphenation penalty, as you can see, what you get is a paragraph which is not hyphenated anymore, and this time you get a slightly different overstretch clue here, which is this empty blue triangle pointing upwards, indicating that the decision of the algorithm is respected, but the scaling exceeds the theoretical value of 1. If I go down to infinity, as you can see, the penalties become infinite, and so it becomes mandatory to hyphenate at every point. So
this is what tech does, by the way. I'm not responsible for it.
Which is a good thing. So what about experimentation? Let me advertise the final feature, which is actually quite cool to have in this kind of tool, which is the properties tooltip here. So as soon as you activate the properties tooltip, you will get some feedback on the performance or the actual results of the algorithm in question if you click on the paragraph here. So with the properties tooltips activated, every time I move the mouse on a line, I will get some interesting information computed by the algorithm itself. So for instance, the line width. Here I'm also getting the scale, the scaling of the line, the fitness class because I'm using the Knuth class algorithm, the badness of the line, and also the demerits. The content of this tooltip will depend on the kind of algorithm that you use, obviously.
Now, if I move the mouse to the left margin here,
I will get a paragraph-wide tooltip containing a number of useful information. So, for instance, the vertical size of the paragraph, the number of lines, pass to, meaning that tech had to use the tolerance threshold instead of only the pre-tolerance one, and the total demerits of the paragraph in question. I can also see, because I'm using the graph version, that this particular solution has been chosen out of 173 possible layouts. And on the other hand, if I switch to the dynamic version, which again gives me the same result, then the contents of the tooltip is going to be slightly different. It will tell me, as written here, that this paragraph was actually chosen out of 2 remaining active nodes. This is to be compared to 173 actual solutions if you use the full graph version. Let me make a quick transition to the rest of the live talk by mentioning something which is absolutely critical in the efficiency of this platform for experimentation and demonstration purposes. Again, all this graphical user interface actually does is manipulating a number of data structures which are also available from the command line in an interactive way from the read-eval print loop, actually, as a matter of fact. And let me just give you an example of this. Every time the paragraph is redisplayed by the interface, as you can see here happening in real time, all the GUI does is actually call a function which is called makeParagraph. Sorry for the lack of imagination. And this is a function which I obviously can also trigger from the command line, as you can see here. So calling makeParagraph from the REPL actually gives me the exact same programmatic object that is displayed by the GUI, and this programmatic object I can use the regular interface, and for instance I can inspect it with an inspector which is here, and everything works in parallel.
Okay, let's switch back to the slides. Thank you. So that's the current state of the platform right now. I would like to say a word about the software engineering aspects, because for as much as typesetting is a hobby and also an application domain for me, my main research area is software engineering and programming paradigms. So this is written in a language which is called Common Lisp. It's a multi-paradigm language. So a paradigm is basically a way to express yourself in a programming language. Being multi-paradigm for me is extremely important, because it's like having a single programming language which is actually like this gigantic toolbox in which there is plenty of solutions for expressing yourself, as opposed to mono-paradigm languages which would force you to do stuff in their own way. For instance, Haskell, which is a perfectly nice and very elegant language, but which imposes a purely functional paradigm on you, okay? So one of the main consequences of using that kind of programming language and being multi-paradigm is actually the concision of the code. And as much as you're concise, it means that it's easier also to maintain, to develop, to debug. And so it's perfect for experimentation and rapid prototyping. So for instance, this gives you an overview of the size of the project. The biggest part is actually the GUI boilerplate. It amounts to approximately 800 lines of code. The implementation of the hyphenation engine, which basically is Liang's thesis, it's only 150 lines. The lineup computing, which means the pre-processing of the text before the typesetting algorithm runs, so kerning, ligaturing, hyphenation, and all that stuff, it amounts to 500 lines of code. Most of the algorithms are implemented in between 150 lines and 450 lines. And for the example of the Knuth-Plas algorithm, for instance, there is a total amount of 700 lines, which means that both version, the dynamic programming optimized one and the regular graph one, amount to 350 lines each. So this is quite short, okay? So it means, again, that it's very easy to play around with that kind of tool. A lot of the concision of the code, like I said, comes from being multi-paradigm. So I'm just gonna give you two examples of different paradigms which help me avoid duplication at most and be as concise as possible. So there is a part there is a large part, actually, of the software which is written in an object-oriented fashion. So, for instance, here you can see there is a base class at the top of the picture for the paragraph, for the representation of the paragraph objects. So a paragraph essentially has a width, a disposition, flush left, justified, blah, 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 and a number of lines. And the GUI, for instance, when it needs to typeset the paragraph, is only interested in that. But depending on the algorithm you use, a paragraph may have additional properties. So for instance, in the case of the Knuth-Plas algorithm, I know that this algorithm uses a number of passes which might be different from paragraph width to paragraph width. So I want to remember that. I also, as you saw, for feedback purposes, I want to remember the total demerits for a paragraph. So I'm going to store that somewhere. And then, what you can see here is the notion of multiple inheritance at play. A paragraph as formatted by the dynamic version of the Knuth-Plas algorithm, so it's called KP dinpar here, is actually both a Knuth-Plas paragraph, so it has demerits, it has a pass number, but it also has a remaining number of active nodes in the active list at the end of the algorithm. But essentially, this is also a regular paragraph. So when you pass that object to the GUI doesn't know all the details. It only knows about this part of the object, and that's all it needs to type to render the paragraph on screen. Okay? But if you want to implement a properties tooltip giving you some feedback on algorithm-specific properties, then what you have is a polymorphic function which actually knows the exact class of the object. Okay? So there is a lot of code reuse like that. There is essentially no duplication thanks to the object orientation. Another way, and this is going to be my second and last example, another way to avoid duplication is to write the code as a mixture of object orientation and functional programming, for instance. So in this example, what you can see on top is a call to a function which is called makeGraph. Again, sorry for the lack of imagination. The makeGraph function creates a graph. Thank you very much, ladies and gentlemen. So this graph is when you want to compute the whole possibilities for breaking a paragraph into lines. Okay? If you want to know the exact number of possibilities and what they are, you will create a complete graph of solutions. Okay? My implementation of Duncan works like that. So there is this function which creates a graph. But the graph can be used by any other algorithm, because if you have all the possible solutions, it means that you're just not optimized, and that's all, okay? So the graph version of the Knuth-Plas algorithm will naturally use also this function to compute the graph, but there is one slight problem, which is that in the default implementation, the solutions are considered correct if the scaling of every line doesn't exceed an elasticity of a factor of 1, okay, either in stretching or in shrinking. Okay? But the Knuth-Plas algorithm doesn't do that. It doesn't only consider the stretching of the lines, it computes the badness. And if you consider the pre-tolerance or the tolerance, the badness or the stretching may actually exceed 1. Okay? So it means that I would be interested to have the full graph of solutions, but the way the Knuth-Plas decides on the next possible breakpoints is different from the default behavior. So it would be completely silly to completely duplicate the makeGraph function just for the case of the Knuth-Plus algorithm. So instead of doing that, what you can do, and this is happening here, what you can do is parameterize the code which computes the next possible breakpoints given a specific position in the lineup. And if you implement that through a function, then you can pass that function as an argument. And this is why it's why this belongs to the functional programming paradigm. This is called higher order functions. So you can pass a function to perform some computation as an argument to another function. And it avoids the complete duplication of the full implementation of the makeGraph function. Okay? So that's just two examples explaining why the platform is actually quite concise. The last thing which also is very important is that in this language, which actually is homoiconic and fully reflexive, when the program is running, you have complete and exhaustive access to every live object in the application. You also have the ability to rewrite functions on the fly, so you can even modify the code while the code is running, okay? So with a system like that, the GUI is actually just one possible front end to the live application, and the REPL, or as Barbara was saying earlier, the command line is actually just another front end. And both front ends are completely bidirectional. You can read stuff, but you can also rewrite stuff on the fly, okay? And this helps me considerably for experimentation purposes, because it becomes completely trivial to, out of curiosity, ask a number of questions and, for instance, do some statistical data collection and create charts of any kind of stuff that you might be interested in. You just need to introspect the live application, retrieve the data you're interested in, and plot that in one way or another. I'm just going to give you a couple of examples, and that will be the end. I don't know how I'm doing 5. That's perfect. It might be the first time ever that I will finish a talk on time. And that's probably because half of the talk was pre-recorded. Okay, so what about the graph size, okay? In 20 lines of code, I can plot that chart, which gives you the size of every graph for every width of the paragraph possible, okay? You can do whatever you want with that. What about the number of possible solutions for given a specific paragraph width? As you can see here, and that's based on just the exploration of the graph of possibilities, what you can see is that at most in this specific case, you can have up to 400 possible solutions for computing correctly a single paragraph, okay? And this happens at approximately 350 points wide, okay? This is just an example. Another example, how many overfull or underfull lines you have per paragraph width. It takes 10 lines of code to get that. How many hyphenated lines? It takes 6 lines of code, and so on and so on. What about the average scaling for every algorithm? This is what you get in 8 lines of code, and as you can see here, for instance, the green line is the Barnett implementation, so it's striking that Barnett has a tendency to compress a lot compared to the other available algorithms. What about the scaling variance? Well, as you can see, and this is comforting, you can see, for instance, that the Knuth-Plus, it's the yellow one, the Knuth-Plus algorithm has a tendency to avoid the too high a variance. Can you guess why? This is pretty obvious, in fact, because the variance in scaling means that you get a lot of adjacent demerits in the face. And by default, adjacent demerit costs a lot. It costs 10,000, I think, or something like that, okay? So that explains why probably the text algorithm avoids too variant scaling across the lines of a paragraph. To conclude this, I would like to give you a final example, but which is also an anecdote, actually. This occurred less than a month ago when I was preparing the talk. And this, I think, illustrates pretty well the interest and the benefit we have in having a platform like that. So at some point, I was getting curious about text view on the competition. So the idea is, if you format a paragraph with somebody else than tech, what would be text evaluation of the quality of a paragraph rendered by maybe the best fit algorithm, for instance. Okay, so the idea is simply to format a paragraph with any other algorithm and then compute the demerits for the paragraph in text term. Okay, so this takes 14 lines of code, and this is what you get. And what you can conclude pretty easily from this picture is that, but you all know that, TUG is an extremely modest guy. It thinks it's the best. But then again, it's normal because as you always know, as you all know probably, TUG does find an optimal solution according to its own criteria. Okay? So it's comforting. It means that probably my implementation doesn't have too many bugs. But then again, I looked at the picture slightly more closely, and if you look at that particular spot, which occurs around 430 points wide, then there is something weird going on. This curve is for the best fit algorithm. Well, at least it's not the best fit in the Knuth sense. It's my version of the best fit, which is slightly different. And as you can see, the best fit gives you a paragraph which, according to TUG, is better than the solution found by TUG. What? So I thought, no, okay, this has got to be a bug. There's got to be a bug somewhere, right? And in fact, there is no bug. It's perfectly normal. Can you guess why? Okay. Yeah, you can. Why?
The solutions sorted out because they hit another threshold from the values.
From the?
For text default values in your current level of experimentation, thrown certain solutions out, and they were accepted by testing.
This is almost it. Not exactly, but this is the direction. Any other ideas? Okay, my implementation of the best fit doesn't care about passes, and it works on a pre-hyphenated lineup. So it means that, So what's happening here is that the best fit implementation will find a solution with, actually, in that particular situation, one hyphen, but TUG finds a solution without hyphenating the lineup. And what happens is that if you calculate the demerits for the two solutions, the one with hyphens is actually better, even in text term, than the second one. And also, this is, once you come to think about it, this is pretty obvious because, you know, the hyphen penalty is what, 50 by default. So it's not much compared, for instance, to adjacent demerits, which is 10,000. Okay? So I finally discovered that, and then I thought I've been using TUG for like 25 years maybe, and I never realized until 3 weeks ago that even in text terms, when it finds a solution without hyphens, it will stick to that solution, even though, in its own view, an hyphenated paragraph could have less demerits than the first one. So then I thought, how many times this happens? Okay, that's a fair question. And then it takes one line of code to get the answer, because then I computed this chart, I'm done. And as you can see, when you see the purple curve on top of the other one, it means that the demerits for the solution with hyphenation are actually less than the demerits with a not hyphenated solution. Okay, and that gives you a view of a general overview of the answer to the previous question. Okay, so that's it. So very quickly to conclude. The platform now is relatively stable. I'm not touching much the internals anymore, so there is a lot of room for doing interesting work. I want to study more literature. By the way, if any of you have at hand the Barnett or Duncan original papers, I'm interested because I couldn't put my hands on those, so I would like to have those. With this platform, it will become extremely easy. I've already started doing so, actually, to think of, you know, extensions, potential extension to the Knuth class. I've got a couple of ideas of my own. Work on nice ideas for reverse detection and reverse plotting, for instance. Try out new algorithms. I also want to provide a tighter integration between the GUI and the lineup. For instance, I want to be able to modify the code from the GUI. This is not going to be so complicated, but that's just the state of the art right now. And many other things, which I'm sure you have nice ideas about, and I'm willing to hear what you think about this. Thank you very much. That's the end.
Thank you, Didier. We have 3 minutes for questions.
Not exactly a question, but a possible addition.
Yeah.
Microtype.
Microtype, obviously. Yeah. Flexible kerning, stuff like that. Lots of interesting things.
You showed us how to influence the handling of underfull and overfull boxes in your system. Is that the effect is that a refinement of the well-known latex commands, fussy and sloppy? Yeah. Most embarrassingly, I've never looked up their bodies.
Okay, so as far as I know, sloppiness is implemented in terms of adjusting the tolerance thresholds, right? Okay. So obviously you can do that graphically, but my implementation of overshrink and overstretch is something different. It lets this was just for the fun of it, actually, for adding one more bell and whistle, you know. So you let the algorithm do its job, and at the end, if you spot an underfull or an overfull line, you have the ability to override the decision of the algorithm and do all kind of nonsense, like compress so much that you cannot read it anymore or anything. This is just to play around with the concepts, that's all. But the overstretch facility is not exactly the same thing as sloppiness.
Maybe you talked about, but I didn't hear it. I wonder how big is the influence of the language on the different hyphenation algorithms, and maybe also of the font, especially with the ligatures and so on.
Yeah. So
another thing, maybe you know, Hans Haaren just implemented a new page-breaking paragraph building algorithm for context that uses more passes. Maybe it would be interesting to implement it.
Yeah. Okay. So about the font, currently the font is hardwired in the platform, but it's actually extremely easy to change it. It's only one line of code. Right now, I'm using 10-point Latin modern font, but actually I have written a TFM parser library for Lisp. So I'm using that to retrieve all the font information from a TFM file, and it means that if you want to use another font, provided that the font is installed on your machine, all you have to do is change the path name to the TFM description file, and you get another font. So it's really not that hardwired.
Last question.
If I remember correctly, Knut states in the textbook that about 80% of his paragraphs could be rendered without hyphenation, and he was pretty proud on this. And in the 80s, doing the hyphenation was just expensive, but now it's not. So would you advocate having at least a switch in the engines? That would be 2 lines of code to switch off the first pass?
This is a very interesting point, and which that allows me to give you also an important precision. I am not interested in an exact replica or a clone of the Knuth-Class algorithm, because I'm using a very high-level language, and I don't want to be a slave to the ancient data structures of Fortran or whatever language of the time. And one consequence of that, for instance, is that again, correct me if I'm wrong, but the way the Knuth-Class algorithm is implemented is that at the time, hyphenation was considered expensive. So Knuth said, okay, we're going to do one pass without, and then if really that doesn't work, blah, 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 blah. So what I'm doing here, because let me get back to the picture if I can. You remember the hyphenation clues that I have. Oh, so this doesn't work anymore. If you remember, I have the ability to put visual clues at the precise hyphenation point in the paragraph. So I want to keep that even if the algorithm doesn't use hyphens. So the way I do it is systematically hyphenate my lineup. And then the way I implemented the Knuth-Class algorithm is that if I'm in pass 1, I'm just ignoring the hyphenation points as potential breaking solutions. So it's different, but I don't care. My point is not to copy the algorithm, just the logic of it.
Thank you again, Didier.
Thank you.